This is the PowerPoint for the Harris Academy Greenwich Sixth Form Virtual Open Evening and is intended for all those students interested in studying A-level chemistry at Harris Academy Greenwich. So the purpose of this is to give you a little bit of an overview for what A-level chemistry is like at Harris Academy Greenwich and to introduce you to some aspects of the course as well as your potential areas for where you might go once it's over. Members of staff involved in the course are on the screen there. So it's Mr. Beach, that's me, I'm the main chemistry teacher at Harris Academy Greenwich, but we also have Miss George and Miss Mackinday that help us at Year 12 and Year 13 as well. Our email addresses are at the bottom of the screen, so if you require any more information about the course that's not in this PowerPoint, just drop one of us a line and I'm sure we can get back to you and answer your query. So, welcome to A-level chemistry. I wanted to do a little bit of a start off by giving you a little bit something to think about, and that is, what do the following things have in common? So, listed on the screen there are paracetamol, a sweater from Primark, a can of baked beans, a diamond ring, and an iPhone. If you're interested to puzzle that one out, you might want to pause the video, but the answer is coming imminently, and that is that they all are a product of chemistry. So every single one of those things on the board there is a product of chemical thinking. Chemists are involved heavily in the production of all of those things. And the key point of me pointing these things out to you is to make you aware of the involvement of chemistry permeating almost every aspect of your everyday life, whether that be the drugs that we take when we're sick, to the clothes that we wear, even just in terms of the fabric that they're made from, or the chemicals that are used to dye the fabric. It's a massive, massive industry. To the food that we eat, the additives and the preservatives that keep the food alive, or maybe not alive, but useful to us as we're going through. Diamond ring, getting materials, raw materials and resources from around different aspects of the globe. And an iPhone, developing the plastics, the conductive materials, the materials chemistry that's needed. So it really does permeate every single aspect of our life, and the skills of chemists are incredibly useful to a functioning global economy. So, studying A-level chemistry, where will this course take me, and what does a course in A-level chemistry involve? Well, let's start off with the first of those two questions. Where will this course take me? Well, there are lots of reasons why people might want to do an A-level in chemistry. You might be thinking of university options after you've finished your A-levels. If you visit the website bestcourseforme.com, it will tell you that the top 5 degree courses taken by students who have an A-level in chemistry are chemistry, biology, preclinical medicine, mathematics, and pharmacology. A lot of people choose to study chemistry at A-level, not only because it's their favourite science, but it's because it's the only science subject, more often than not, that you require to do a degree in medicine. So 9 times out of 10, your typical offer will say 2 sciences and maths. One of those sciences must be chemistry. So if you're interested in going into medicine or pharmacology, chemistry is an absolute must for you. But a lot of people go on to study biology and maths as well. There are more details on that website, bestcourseforme.com. So if you know what you want to study at university after your A-levels, it provides lots of really good information as to what A-levels are the best thing for you, and also the UCAS website is an invaluable resource. You might even be thinking about careers post A-levels and post universities. So studying chemistry at A-level or degree opens up plenty of career opportunities, and like I've already said in this PowerPoint, there's so many things that chemistry is involved in our everyday lives. So this is just a very short list here. It can be an analytical chemist, chemical engineers who definitely go on to earn quite a lot of money, clinical biochemist, pharmacologist, a doctor, a research scientist, toxicologist, environmental consultant, higher education lecturer, secondary school teacher like myself, patent attorney, science writers. Okay, that's a very sort of a short list there, but there's loads of other things you could go through. So I've already mentioned how chemistry is involved not just in pharmacology and drug manufacture, but also in the food we eat, the clothes we wear, the materials that we use in everyday life. So yes, absolutely, chemistry skills are vital for the workplace and vital for a functioning economy. So the course itself then, that's all towards the end of it. This is what we're doing during the course. So at Harris Academy Greenwich, we follow the AQA A-level chemistry course. And the course is split into 3 very important aspects. They are physical chemistry, inorganic chemistry, and organic chemistry. The topics that you see up on the board there are what you would cover in your first year of study as you go through AQA level chemistry, the full course being 2 years. Some of these topics you might recognise from GCSE, some of them you might not. So atomic structure, amounts of substance, moles and chemical calculation, bonding, energetics, enthalpy changes, kinetics, rates of reaction, equilibria, Le Chatelier's principle and KC, oxidation and reduction, redox equations. You might reasonably recognise some of those things from your GCSE course, and we'd look to expand those as we moved into A level. Inorganic chemistry looks at the concept of periodicity in our first course, so this concept of repeating trends or patterns in the periodic table, and we put a particular emphasis on studying group 2 and group 7 of the periodic table, their reactions. You might have studied some organic chemistry in GCSE. You would have looked at crude oil, for instance, and that's massively expanded upon in A level. So one of the biggest differences is the amount of organic chemistry that you do, because it's over a third of the course. So we'll talk about alkanes. We'll talk about other things like halogenoalkanes, alkenes, alcohols, and doing some organic analysis as well. So all this is just the AS level of the course, or the first year of the course. Moving into year 2, we've still got those 3 main strands, that physical chemistry, that inorganic chemistry, and the organic chemistry. Some of these topics are more likely to look more alien to you. Okay, so the year 12 and the year first year topics might look more familiar. As we're progressing through this course, we start to talk about more complicated aspects of chemistry. So physical chemistry starts to involve thermodynamics, rate equations, equilibrium constants, and electric potentials in acids and bases. All of the topics you see here will build directly from stuff you've looked at in year 1. So thermodynamics will build on what you've done for enthalpy changes. Equilibrium constants will look at what you've done with Le Chatelier and equilibrium in year 12, for instance. Electric potentials will look on your redox chemistry from year 12. So this is basically the next stage of your course as it would be from year 12. So there's a natural progression running all the way through. And these are the structure of the A-level exams, which you sit at the end of year 13. So these are the exams that you will sit that will determine what grade you get for AQA A-level chemistry. At the end of year 12, you sat 2 papers. For the real exams at the end of year 13, you will sit 3 papers. Each paper is 2 hours long. Paper 1 is worth 105 marks, as is paper 2. Paper 3 is worth 90 marks. And you can see what percentage of your A-level grade each paper makes up. Like AS, paper 1 covers half of the physical and all of the inorganic, and paper 2 covers half of the physical and all of the organic. Paper 3 is what we call a synoptic paper. They can assess absolutely any content that appears on that paper, but there is a big emphasis on paper 3 on practical skills. Relevant practical skills will come up in paper 1 and paper 2, but there is a larger emphasis on practical within paper 3. You will notice in paper 1 it's all short and long answer questions, so 105 marks of short and long answer questions, whereas in paper 3 you'll have 40 marks of questions on practical techniques and data analysis, 20 marks of questions testing across the specification, and then you will have 30 marks of multiple choice questions on paper 3. So often paper 3 is the more challenging one of each of those 3 sections. Your marks for each of these exams will be totaled, and your total marks will combine to give you a grade from A star all the way down to E, and then U is the fail grade. I've mentioned a lot about the relevant practicals that will come up on your exams. Okay, and you will be required to carry out a fair amount of practical work during your A-level studies across the 2 years. Chemistry is, after all, an incredibly practical subject. You are required by the course to do a minimum of 12 practicals across the course. You will carry out these practicals and you will be expected to be able to complete these practicals up to a reasonable standard to pass the course. Not only for that, but because they will be assessed in the written aspects of the course as well. Some of these practicals you might think you've seen before, you might think you have a good understanding of what they might be. So making up a volumetric solution and carrying out a simple acid-base titration, you might have seen something similar at GCSE, and we're building on that. Measuring an enthalpy change, investigating how a rate of reaction changed with temperature, again that third one, you might have seen something similar at GCSE. Doing test tube reactions to carry out testing for some ions. Again, you might have seen that at GCSE if you did triple. But then as we go further through the course, we start to get into those year 2 things, and it starts to get a little bit more complicated. So measuring the electromotive force of an electrical chemical cell, preparation of a pure organic solid and test of its purity. These things require a little bit more skills that we'll build throughout the course. So you will do a lot of practical throughout the course, and you will be provided with a lab book to record all of your practical work in. We will teach you how to record the practicals. You will be awarded a pass or fail as a result of completing a minimum of 12 practicals across both years. So we record various aspects of your competence in doing these 12 practicals, and by the end of the 12 years, we record whether you've passed or failed a practical endorsement. It is the expectation that most, if not all, of the other students we have will pass the practical endorsement. This is in addition to your A-level grade given from the results of your exams at the end of year 13. So the results document that you open up on your results day in year 13 might read grade A in chemistry plus a pass in the practical endorsement, or grade B in chemistry plus a pass in the practical endorsement. So a practical endorsement is assessed separately, but also it's assessed within the context of the exam. So you will get questions about these practicals. The entry requirements to get on A-level chemistry at Harris Academy Greenwich are as follows. We would like you to have a 5 in English. It's really important that you could write clearly and concisely with the most important information necessary. The mathematical standard is a little bit more than what most students are accustomed to in their science lessons at GCSE. So we ask for at least a grade 6 in maths. You can definitely expect to do quite a fair bit of maths in your A-level chemistry course. And hopefully it stands to reason that we'd ask for a grade 7 in combined science trilogy or a 7 in triple chemistry, which either one you do. You are at no disadvantage having done just the trilogy course. Okay, we will teach you everything you need to know to be successful. Just to finish up, I thought it'd be nice to show you some examples of student work that's been going in their books during lessons. So this is an example of one of our students in year 13, and the work here surrounds calculations of pH in our acids and bases topic.